Okay, the second part to section R.4, we're still factoring, is to factor by grouping. Now, anytime you're asked to factor anything, the first thing you're always going to look for is a GCF, like we saw in the last video. All right, factor by grouping is a method that's used when there are 4 terms in your polynomial. To do factor by grouping, the first thing you're going to do is you're going to group the first 2 terms. Your second step will be to group the second 2 terms. Now remember, in math there are several grouping symbols, one of which is the parenthesis, and so that's what we're going to use to form our groups. Alright, then once we get our groups made, we're going to factor the GCF from the first group. Alright, then we'll factor the GCF from the second group. Alright, then the last thing we're going to do is factor the GCF from the remaining 2 terms. Alright, I'm going to work a couple of problems where we go through all of these steps. Alright, the first problem we're going to look at is r squared s plus 3r squared minus 5s minus 15. Alright, and my instructions tell me to factor. Alright, so here's what I'm going to do. I'm going to factor. Because there are 4 terms, here's term number 1, term number 2, term number 3, term number 4. So 4 terms, I know I'm going to use factor by grouping. I'm going to follow my instructions. So group the first 2 terms. So I'm going to put parentheses around the first 2 terms. Then my instructions tell me to group the second 2 terms. So I'm going to put parentheses around the second 2 terms. Then I'm going to factor the GCF from the first group. So looking at the first group, I want to find the GCF between r squared s and 3r squared. Alright, numerically I don't see one. My coefficient is a 1 and a 3. The only factor they have in common is a 1. So if I factor it out, it doesn't change anything. Alright, but when I look at the letters, I see they both have an r squared. So I'm going to factor that out. Alright, if I factor out an r squared, I'm left with s plus 3. And then I bring down my minus sign. Then I look at the second group. My step number 4 says factor the GCF from the second group. So when I look at 5s minus 15, I see a GCF of 5. So now when I factor out a negative 5, remember we brought that minus sign down, so we have a negative 5. What times negative 5 makes negative 5s? Would be an s. And what times negative 5 makes negative 15 would be a positive 3. Alright, now if you'll notice, what's in parentheses is the exact same. If your polynomial will factor, then these 2 things must be the same. If they're not the same, it either will not factor or you've not pulled out the appropriate GCF. So go back and check the GCF because I won't be giving you any problems where they won't factor. Alright, so now we're to the last step, which says factor the GCF from the remaining 2 terms. And if you've done this correctly, that GCF is going to be what's in parentheses, the s plus 3. And then in the remaining parentheses will be my r squared and my minus 5. Alright, and that should be the answer there. You can check it by multiplying everything back out to make sure it gives you your stated problem. Alright, let's look at another example. Let's look at, let's say we have the problem 4m squared minus m squared n plus 4n minus n squared. Alright, we're going to group the first two terms. We're going to group the second two. Alright, so we've made our two groups. Now we're going to look at the first group here and factor out the GCF. So letter-wise, they both have in common an m with the smallest exponent of 2. And then when I factor out the m squared, I'm left with 4 minus n plus, alright, I have 4n minus n squared, no numerical GCF, but they do have in common an n. The smallest exponent is a 1. Alright, so when I factor out the n, I'm left with 4 minus n. Notice what's in parentheses, 4 minus n, 4 minus n, the exact same. Remember, if they're not the exact same, sign and all, you've either not factored out the GCF or it's not factorable. And I don't intend to give you any that are not factorable. Alright, the last step is to factor out the GCF between the two terms, which is going to be what's in parentheses, 4 minus n, and then m squared plus n is what remains.